Okay, guys, so today we are going to start by synthesizing, which basically just means like putting a whole bunch of information onto our periodic table. All right, guys, so we are going to start with a blank periodic table, and then we are going to put a whole lot of information onto our periodic table. So before we begin, you need to go ahead and gather your materials. So for this video, you're going to need some normal pens or pencils, and then you're also going to need a variety of colored pencils. I would say the more colors you get, the better. You will also probably want some colored pens or some Sharpies, something to write over your colored pencils. So go ahead and pause the video and then find those materials and come back. All right, friends, so now that you've gathered your materials and come back, we're going to start by just going over the periodic table in general. So the periodic table is arranged by increasing atomic number, and that's the number that's up here in the top left. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc., etc. Okay? So it's arranged by the number of protons. So each time that you move up one, you're adding a proton. It's also arranged by properties. So things that are in the same group or family have very similar properties. And then as we go across from left to right, there are certain trends or patterns that we start to notice as we go from left to right. And so today, what we're doing is we're taking a whole bunch of information and we're going to compile it into our periodic table. And the reason why this is so good and so important is because you're going to be able to know a whole lot of stuff in a little bitty space. And there's not a periodic table that you can just print off online. There's not one that exists in the book that has all of this information in one place. I would even go so far as to recommend you laminating it or getting a page protector for it. I've had high school students come back and tell me how useful it was when they took ICP or when they took chemistry. So it's definitely something that you will want to hold on to and cherish forever. The first thing that we're going to do is we're going to label our periods. So periods go from left to right. So they are the rows that are in the periodic table, and there are 7 of them. So go ahead and take your pen and label the periods 1, 2, 3, 4, 5, 6, 7. You can also write the word periods over here if that will help you. The period number is going to tell you how many shells there are on the periodic table or in your atom. So the shells are like in the Bohr model where period 1 has 1 shell, period 2 has 2 shells, period 3 has 3 shells, etc. So go ahead and label the periods. The second thing we're going to do is we're going to label the groups or families. And the groups or families are the ones that go up and down. And there are 18 from start to finish. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18 is all the way over here on the right. So periods go across, families go up and down. The second thing that we need to do is we need to color in or shade in our metals, metalloids, and nonmetals. Most of the periodic table are solid metals. But as you go from left to right, you get less metallic and more non-metallic in nature. So you get less shiny, you get less bendable, and you get to become where you're more likely to be a gas, you get a little bit lighter, you get dull, you get brittle, those types of things. And then this group right here in the middle are called metalloids, where they have some properties of metals and they have some properties of non-metals. So I always like to start with my metalloids because that's kind of the boundary between the other two. So boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and astatine are your metalloids. So I have them shaded in orange. Pick a color and go ahead and pause the video and shade in your metalloids. The second step that we're going to do is we're going to label and color in our non-metals. So everything to the right of our metalloids are non-metals. So you can see that it's everything over here. I have shaded this in yellow. The other thing that I want to point out to you is that hydrogen is actually on the left-hand side. So even though it's on the left-hand side, it is considered a non-metal. It has properties like the other non-metals do. So go ahead and pause the video, pick a color, and shade in your non-metals. All right, and lastly, we're going to shade in our metals. So everything else are metals. So I have them shaded all in red on my periodic table. The only thing to be careful of is that from 107, so basically like almost this entire bottom row, we're just going to leave it blank. We don't actually know whether these have properties of metals, nonmetals, or metalloids because they exist for such a short period of time before they start to decay that we really don't know their properties. So this bottom row we're going to leave blank. Also, don't forget about the bottom 2 rows down here. Remember that these lanthanides and actinides are actually part of period 6 and 7. So go ahead and pause the video and color in your metals. All right, now that you guys have shaded in your metals, what we need to do now is we need to write in our key. So you need to shade in or create a box for the metals, metalloids, and non-metals. So go ahead and add that to your key. The next step is going to be to outline our liquids. And there's really only 2 elements that exist as liquids at room temperature. So room temperature is like 25 degrees Celsius. So bromine right here, number 35, and mercury, number 80. Go ahead and outline those with a dark pen or marker. These are the only 2 elements that exist as liquids at room temperature. Now we're going to label the gases. The first gas is hydrogen gas, so make sure you label hydrogen, outline it. I have mine outlined in green right here. And then nitrogen, oxygen, fluorine, chlorine, and the whole group of 18 are all gases at room temperature. Okay? So nitrogen, oxygen, fluorine, chlorine, and then all of group 18, these are your gases at room temperature. You can assume that if we have not boxed it out, like if we have not outlined it, that everything else is going to be a solid. So the majority of this periodic table are solid metals at room temperature. Also, go ahead and update your key. So I have a blue box for liquids and I have my green box for gases. The last thing we're going to put on this side of our periodic table is we need to star or put like a little asterisk next to some of our elements. So we're going to put an asterisk above everything that's 92. So here's 92, no asterisk. 92 is the last naturally occurring isotope, which means we can find it in nature. So elements 93 through 118 are going to get a little asterisk. This asterisk means that it's synthetic. Synthetic means that it's made in the lab. So go ahead and put synthetic, go ahead and put your asterisk on everything starting with 93 through 118, and then add that to your key. This next part is where things get a little complicated. So if I were you, I would go ahead and turn your periodic table over to the other side, to the blank side. And when you turn it over, the first thing you'll want to do is you'll want to label your period numbers 1 through 7, and you'll want to label your group numbers 1 through 18. So go ahead and pause the video and label your periods and label your groups. For this one, this is where you're going to need all of your colors. You're going to need all the colors of the rainbow. I didn't have quite enough colors, so I kind of had to double some of mine up, and I had to repeat some of them, but that's okay. So anytime that you are in a group or family, you're going to have very similar properties. And so some of these things have special names, and we're going to shade them in like that. So group 1, okay, so we know it's group 1 because there's a 1 at the top here. So group 1, with the exception of hydrogen. Hydrogen is not part of group 1. Group 1 are the alkali metals. These are very, very, very reactive metals that will actually explode if you put them in water. So that's a pretty interesting little experiment that hopefully I'll be able to show you. Group 2, color that a different color. These are your alkaline earth metals. Still very reactive, but not quite as reactive as group 1. The next family is actually a really large group. So groups 3 through 12, all of these are the transition metals. Now remember, we're not coloring anything on the bottom row because we don't know much about them yet. But groups 3 through 12, these are the transition metals. These include things that are pretty common to you, like iron and nickel and copper and zinc. You might have heard about some of those before. And then we're going to go to family 13. Families 13, 14, 15, and 16. These 4 families right here are comprised of both some nonmetals, some metalloids, some metals, and so they're really kind of a mixed bag. So these don't have special names. These are just named for the elements that appear on the top. So group 13 is the boron family. So go ahead and shade in the boron family and add it to your key. Group 14 is the carbon family. Go ahead and shade that in and add that to your key. Group 15 is the nitrogen family. Go ahead and shade that and add that to your key. Group 16 is the oxygen family. Go ahead and color that and add that to your key. Group 17 gets a special name because group 17 is a special group of nonmetals, which we call the halogens. They're actually the most reactive nonmetal group on our periodic table. So go ahead and shade in group 17 and label it halogens. Finally, group 18 right here, again, not the bottom, but group 18 from helium all the way to radon, these are your noble gases. This entire family is made up of gases, and they're called noble gases because they don't like to react with anything else on the periodic table. The last thing we need to do on this side of our periodic table is that we have the lanthanides and actinides. So you're going to shade in the top of the bottom. So here I have it in orange. These are the lanthanides. They're named for the first element in the row. And then the second one is the actinide series. These are grouped together because they have very similar properties. And so we need to label the actinides on our key as well.